Hi everyone, Assalamualaikum. In this video, we will continue with example 4 under linear equation for first order ODE. Solve the initial value problem x dy over dx minus y equals to x cubed cos x given the initial condition y pi equals to 0. Right? From the given question here, we have y to the power of 1. Okay? And there is no term containing y for coefficient of dy over dx and the function on the right hand side. So means this is linear equation, right? And to solve linear equation for first order ODE, first step, we need to write into the form of dy over dx plus pxy equals to qx, right? From here, when we compare in the general form, the coefficient of dy over dx must positive 1. Okay? But from the given question, we have coefficient of dy dx equals to x here. Okay? So, we need to divide each term by x. Okay? We need to divide each term by coefficient of dy over dx. So that we can write coefficient of dy over dx equals to positive 1 after we simplify. And after we simplify, we get this. We can simplify x in numerator and x in denominator here. So we get positive 1 dy over dx. And then we can write plus negative 1 over xy. Okay, so that when we expand, we get back negative y over x. And then we can simplify x cubed over x. So we get x squared and then cos x. Alright, then we compare with general term for linear equation. So now we have the first term is dy over dx and the coefficient of dy over dx equals to positive 1. Yeah? And then plus, and then we have term containing x, and then we have y to the power of 1 equals to, and then right hand side we have term containing x, and there is no term containing y. Right? So after that, we can continue with step 2. Okay? Identify px and qx. Right? Right. So from here, we compare one by one. Now we have dy over dx in the first term. And then plus. Then we have px equals to negative 1 over x. Okay? Px must the term beside y. Right? And then qx equals to x squared cos x. Right? Right, after that, we continue with step 3. Find integration of px dx. Okay? So, from px equals to negative 1 over x, we need to integrate. Okay? So, now we have integration of, we replace px equals to negative 1 over x dx. And after that, we can move out negative sign from integration symbol. So we get negative integration of 1 over x dx. Then equals to, we still have negative sign. And then integration of 1 over x dx equals to ln x plus c. But we don't need to write plus c because we still not finish our solution. Right? And after that, from properties of logarithm. Okay? We need to move up multiplication of p here. So now we get m to the power of p. Why we need to use this rule, okay, or these properties? Because when we get the answer ln, we need to write coefficient of ln equals to positive 1. Why? We will discuss later. Okay. Alright, first, from this formula, okay, we can write integration of px dx equals to ln x to the power of negative 1. Why to the power of negative 1 here? Because we move negative sign here means negative 1. We move up here using the properties of logarithm. Ln here means log base e. Okay? So we still can use this formula. Alright? Alright, so now we write coefficient of ln equals to positive 1. Okay, we move up negative 1 here. We move to exponent here using the properties of logarithm, right? After that, we continue with step 4. Find integrating factor IF, which is equals to integration of IF equals to e to the power of integration of px dx, right? So we get IF equals to, we have e here, and then our integration of px dx equals to ln x to the power of -1, right? And equals to x to the power of -1. Right, why we get this? Okay, from this formula. When we have e to the power of positive ln x, we can simplify equals to x. Okay, you can check using your calculator. If you calculate e to the power of ln 2, let's say, using your calculator, you will get the answer 2. If you calculate e to the power of ln 3 using your calculator, you will get equals to 3. Okay, so means that when we have e to the power of ln x, it is equals to x. But make sure that coefficient of ln should be +1. So that's the reason why we must move negative coefficient here. We move up here using the properties of logarithm. Okay, because when we get coefficient of ln equals to positive, so we can use this formula. Alright, so now we have e to the power of ln x equals to x. Okay, so we can compare from here. E to the power of ln x to the power of -1 equals to x to the power of -1. Right, because now we have coefficient of ln equals to +1. Right? And after that, we can write x to the power of -1 equals to 1 over x using properties of indices. Right? From the previous slide, we get qx equals to x squared cos x and if, which is integrating factor, equals to 1 over x. Then we continue with step 5. The solution is y times if equals to integration of qx times if dx. Using this formula, we still have y here, okay, and then we replace if equals to 1 over x equals to integration sign, and then we replace qx equals to x squared cos x times if. We replace if equals to 1 over x and then dx here. Right? After that, we can simplify x squared here and x in denominator. Okay, after we simplify, we get y over x equals to integration of x cos x dx. Alright? Then we no need to integrate the function on the left hand side because there is no integration sign here. But we need to integrate the function on the right hand side because we have integration sign here. And to integrate x cos x dx, the suitable method is integration by parts, right? And when we integrate using integration by part, we have two methods, okay? Either using tabular integral or using integration by parts formula. But to use tabular integral, we need to make sure that the function has term containing repeatable function. Repeatable function means trigonometric function or exponential function. In this case, we have trigonometric function. Means we can use tabular integral to integrate using integration by parts. Okay. So to integrate the function on the right hand side, which is integration of x cos x dx, we can use tabular integral under integration by part. And when we use tabular integral, we need to use table with 3 columns. The first column should be sign, the second column is u, and the third column is dv. Right? And when we use integration by part, we need to choose the function as u and the function as dv. Okay? So from here, we have x is A. A means algebraic function. And we have cos x is T. T means trigonometric function. Okay. From Euler rule, okay, A come first. Okay. So whichever function come first should be U. So from here, our A means x equals to U. And our T means cos x equals to dv. Okay. After that, let we finish column U first so that we know when we can stop the rows. Okay. So when we have algebraic function, we need to differentiate until we get 0. Okay. So from x, we differentiate. Okay. Remember, we need to differentiate in column U. Okay. So from x, when we differentiate, we get 1. And then we differentiate 1, we get 0. Okay. We stop here because now we have the answer 0 when we differentiate. Alright. And after that, we continue with column sign. Okay. We start with positive sign. And after that, we alternate the sign. So we start from positive sign, and then negative, and then positive. Okay. Our last row is row 3. Right. And after that, in column DV, we need to integrate. Okay. So now we integrate cos x equals to positive sin x. And then we integrate sin x equals to negative cos x. Okay. And after that, integration of x cos x dx equals to, we multiply this, we multiply x and sin x, then we put here. Okay. And after that, we multiply 1 and negative cos x, so we put here. Okay. And then, for the last row, we need to multiply in horizontal. Okay. So we multiply negative cos x and 0, but we need to put integration sign and dx at the back. Okay. So negative cos x times 0 equals to 0. And then we put integration sign and dx. Alright. Right after that, we have positive sign here. So we put positive sign here. Okay. Or no need to write positive sign. Okay. And then we have negative sign here. So we put here. Okay. And after that, we have positive sign. So we put positive here. Alright. Then we need to simplify. Okay. So we have x sin x, and then negative times negative equals to positive cos x, and then plus, when we integrate 0, with respect to x, we get constant c. Alright? Right, after that, we substitute here. Okay? So now we have y over x equals to, after we integrate x cos x dx, we get this. Right? So we substitute here. Right? And after that, under linear equation, we need to write y as a subject. So, we need to multiply x in denominator here after we move to right hand side. So, we need to multiply all this term by x. Okay. So, we can write y as a subject equals to, we multiply x and x sin x. So, we get x squared sin x plus x cos x, and then plus cx. Okay. Since x is a variable, so we need to multiply x and constant here. Okay. But if denominator here is a constant, we no need to multiply by constant c here, because constant times constant still equals to constant. Okay. But in this case, we need to multiply c and x because x is variable. Alright. So, the solution, when we solve this equation, this ordinary differential equation, so we get y equals to x squared sin x plus x cos x plus c. This is called the general solution. Okay. But, now we are given initial condition. So, after we find the general solution, we need to find the value of c using the given initial condition. Alright. If the initial condition is not given, this is our final answer because we no need to find the value of C. But in this case, we are given the initial condition. So, we need to continue the next step, which is we need to find the value of C. Right? From the previous slide, we get the general solution is y equals to x squared sin x plus x cos x plus cx. Right? We are given the initial condition. Okay, means we need to find the value of C after we integrate. Right? If the initial condition is not given, this is our final answer. Okay? Alright, so to find the initial condition, we need to identify the value of x and the value of y from y pi equals to 0 here. Okay? So before that, we can name the general solution as equation 1 so that it's easy to refer. Okay? Alright, so from here, pi is the value of x and 0 is the value of y. Okay? Then we can continue with step 6. Okay? Applying the given initial condition to find the values of C after we integrate. Okay? So we need to substitute the initial condition x equals to pi and y equals to 0 into equation 1. Okay? So now we have y0 equals to pi squared. We replace pi into variable x and then sin pi plus pi cos pi plus c pi. Alright? Sin pi equals to 0 and cos pi equals to negative 1. So after we simplify, we get 0 equals to pi squared times 0 equals to 0. Pi times negative 1 equals to negative pi and then plus c pi. Okay? After that, we get c pi equals to, we move negative pi here, so we get positive pi. Okay? Then, we can find the value of c. Okay? C equals to 1 because we can move multiplication of pi here. We move to right hand side, so we get pi over pi, which is equals to 1. Okay? So, our c now equals to 1. Then, we need to substitute the value of c into equation 1. So, after we substitute, thus, the particular solution is y equals to x squared sin x plus x cos x plus, we replace c equals to 1. So 1 plus 1 times x equals to x. So this is the final answer. This is the particular solution. The particular solution means we substitute the value of c into the general solution. Right? The general solution means we leave the final answer in terms of c. Means we no need to find the value of c. But the particular solution means we need to find the value of c because we are given the initial condition. Right? Coming up next, more examples for linear equations. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.